Thank you for continuing with project management training. I am Trudy Robinson. This presentation is specifically covering a PERT analysis as part of a project timeline. The objectives of this session are to understand the formula, the use and the benefits of the Program Evaluation and Review technique, commonly known as a PERT analysis. As described on the slide, the PERT analysis is a probabilistic formula and process. The formula and process is based on having three values: the best case, commonly known as the optimistic, the expected case, which can also be known as most likely, and the worst case scenario, which is pessimistic. This can be used for both timeline analysis and cost analysis. The formula that's used to undertake this calculation is the optimistic value plus 4 times the most likely value with the addition of the pessimistic value divided by 6. So in the simple scenario of taking a journey, you'll have a starting point and a destination. You may be analysing two different options. First, travelling by a highway with no toll, and a far shorter distance which has higher expense of a toll road. In practice, we would know that with the toll we would have an optimistic travelling time of 3 hours. It's more likely to take 3.5 hours, and the most pessimistic is 5 hours. Without the toll, we know that the optimistic is about 4.5 hours, the most likely is 5.5 hours, but there's more likely to have impact from accidents, delays in the traffic, etc. So the pessimistic is 8 hours. In your mind's eye, you'll already understand that the most likely timeline is 3.5 hours. The pessimistic is 5 hours, and the optimistic is 3 hours. Having the mindsets that we do, we would look at the most likely timeline, but we would add a small amount to accommodate for extra stops, unknown circumstances, mechanical issues, etc. So we would usually take the most likely and add a small amount to give ourselves some leeway. This is the principle of the PERT analysis. It takes these three calculations and it uses a standard formula to give that extra leeway. The example that we had set before we'll now do in Excel. So remembering that this is the formula, the optimal time plus 4 times the most likely plus the pessimistic time divided by 6. So it is the optimistic time plus 4 times the most likely plus the pessimistic, and obviously based on the Bomb-Dash theory here, we would need to put this formula in brackets to make sure that this occurs first prior to the division of 6 being undertaken. And we can see that the PERT analysis is 3.67. If we calculate the same for the without toll, we can see that the PERT analysis is 5.75. This obviously depends on the variations between those three figures. So if we had the optimistic as being 3 hours, the most likely as being 5 hours, and the pessimistic as being 8.5 hours, then obviously the PERT analysis changes. Looking at this scenario, any tasks that have a greater variance between the most likely and the pessimistic are the ones that you would usually have some need to undertake a risk analysis to ensure that that particular task was going to be managed in a manner that brought it into line with the more likely or the PERT analysis, so the pessimistic view was the least likely to occur. In Microsoft Project or any other project management tool, the PERT analysis is undertaken automatically. The data is usually entered into a table, and the optimistic, the expected and the pessimistic durations are entered, and then the PERT analysis is undertaken using the same formula. You can change the weightings formula, but in most cases it's best to leave those formulas unchanged. What you can then do in Microsoft Project or any other tool is view the Gantt based on the optimistic versus the expected versus the pessimistic, or the calculation of the PERT.